Today we will introduce changes in the radioactive concentration and air dose rate at Fukushima Daiichi Nuclear Power Station. From daily interviews, we will show these changes using a trend graph for an approximate 1-month period. We will introduce post-March 11th data as the trend this time. First, this shows the changes in the radioactive concentration in the dust around the west gate of the power station. We are measuring the dust concentration in the air every day. We have conducted measurements continually up until now from March 11. Now, the order of data is less than the power of 10⁻⁷ or below the measurable limit. In the trend graph of the second page, we show where the dust concentration largely falls. At present, the concentration limit is a small concentration. Approximately 4 digits for cesium-134 is 2 times the power of 10⁻�3, and cesium-137 is 3 times the power of 10⁻�3. Next, this is the situation offshore. We introduce about 3 points because these have many samples. At first, this is in the North Water Outlet, South Water Outlet, and 15 kilometers offshore over these 3 pages. After the accident, it peaks at about the beginning of April, but gradually decreases by diffusion afterwards. Though the data called ND continued until about October, we conducted operations to decrease the detection limit afterwards. Now we measure that the cesium-137 order is from the power of 10 ± 0 to the power of 10 + 1. Next, page 4. This is the situation in the port. The fourth page shows the inside and outside of the silt screen at Unit 1, and the fifth page shows the inside and outside of the silt screen at Unit 2. The sixth, seventh, and eighth page shows the trend graph in the port. As a whole, it is on a downward trend, and we considered that the high concentrated contaminated water which flowed out once is shut in this port by silt fences. As for the monitoring results, we think that the highly concentrated contaminated water does not leak water now into the ocean because this value does not rise. Next, from page 9, this is an analysis of the subdrain and underground water at the turbine side of the building. Units 1 and 2 are on page 9. Units 3 and 4 are on page 10. Unit 5, 6, and the deep well at the west side of the power station are on page 11. It has been similarly detected at Unit 1 and Unit 2. Especially when it rains, the data of Unit 1 tends to increase. The data itself is almost at a similar level or is falling slowly. And on page 11, it is a situation of ND always at the north side of the power station. Unit 5, Unit 6, and the deep well. Next, this is the situation of soil on page 12. We are measuring at 3 points: the ground, the wild bird forest, and close to the industrial waste disposal in the power station. The analysis of cesium and plutonium is also at a similar level. The situation where the material is released and deposited after the accident continues now. And we think that there isn't any additional releases. Next, this is the situation of the seabed soil on page 13. We are measuring at 2 points: 3 kilometers offshore of Odaka Ward and 3 kilometers offshore of Iwasawa Shore. These analyses are almost at a similar level or on a downward trend. Therefore, we think that there are no additional accumulation and deposits. About the seabed soil, it is just as the situation reported concerning the sampling in the port. Next, this is the situation of the monitoring posts on page 14. It is recently at a similar level or on a downward trend, and at this situation, we think it is stable as the background level in the future. As for further radiation exposure reduction measures, we think that this is the neck point in the future. Next, this is the situation of the air dose in the power station on page 15. We announce this approximately once a month. This is the situation of the air dose in the power station at first on March 23rd and on November 10 now. The color of this cloud mark shows the day when we measured. Please note that the amount of the dose of radioactivity has nothing to do with the color in particular. Generally, on November 10th, you can see that the air dose rate decreased via the removal of rubbles. Besides, this is a situation in the building and the place where the second floor at the main anti-earthquake building, the so-called Technical Support Center, is installed as shown on page 16. The maximum air dose when the first measurements were conducted on March 15th decreased to 6.3 microsieverts per hour because it was 380 microsieverts per hour, and it was a situation where it was a little high, but the local air exhaust ventilator then placed the lead shelter on the window side from March 31st. The highest recorded value on November 30th was the situation when it was 2.3 microsieverts per hour. In the future, because the Technical Support Center at the main anti-earthquake building will be the base of activity in the future, it is believed that attempts to implement dose reduction measures are being done continuously, and the aim is to create an uncontrolled area. As for the situation of the main control room, the blue represents Unit 1 and Unit 2, the orange is Unit 3 and Unit 4, and the cream color represents Unit 5 and Unit 6. At Units 1 to 4, because the radioactive materials in the air are in the main control room under the influence of explosions from buildings, we measured a high value of 90 microsieverts per hour at Unit 1 and Unit 2, and 70 microsieverts per hour at Unit 3 and Unit 4 on April 9. But via later environmental improvements, it was 11 microsieverts per hour and 12 microsieverts per hour respectively on November 23rd. And concerning Units 5 and 6, the cold shutdown was accomplished during the regular inspection of the reactor. It was 0.5 microsieverts per hour or 0.4 microsieverts per hour. This is the air dose rate in the building on page 18. Individual inspections of workers and those conducting investigations are being carried out to prevent overexposure. The situation of the dose of the fourth floor reactor building of Unit 1 and the first floor turbine buildings are shown on page 18. In the main passage, there are two examples of Unit 1 mentioned, as well as information about the units, including the shared pool. In a separate piece of documentation, as we are aware of the spatial dosage rate of the common utilities for each unit, and the common pool, as well as other common facilities, this information has also been attached. The air dose at each unit and floor is understood from recent data. The latest data from April-March to November-October as the data gathering period about the dosage of each unit and floor is mentioned. Page 19 shows the concentration of radioactivity of the accumulated water in the turbine building. As for this, at Unit 3, the situation of the flat movement continues approximately from Unit 1. It is believed that the water, which is pouring out to the nuclear reactor at present, slips into the turbine building via the reactor building. Given that the reactor core itself of the nuclear reactor isn't damaged in Unit 4, there is no damage to the spent fuel pool either. However, because water was included via the turbine building concerning Unit 3, situations such as the rising and falling with the inflow were confirmed. On page 20, the contents of the ingredients in the rainwater are presented. Today we gathered and reported data which was gathered during the accident in March concerning the change of the concentration and the air dose rate of the radioactivity. As mentioned, there is either a decrease or a flat movement of the dose amount and concentration of radioactive particles, and it is believed that the release of radioactive materials is being managed. From here on out, in order to reduce worker exposure to radiation, we plan to continue monitoring the air dose rate and the concentration of radioactivity. In an effort to reduce worker exposure to radiation, the radioactivity concentration and the air dose rate at Fukushima Daiichi Nuclear Power Station will be continuously monitored.